Hey everyone, and welcome to this explainer. Today we're taking a fascinating and honestly sometimes downright dizzying journey through the rapidly changing layers of AI engineering. Look, if you've been paying even a little bit of attention to the artificial intelligence space lately, you know it's moving at just an absolutely breakneck speed. So today, we're going to map out exactly how we got from simple, single-shot text prompts all the way to something entirely new, autonomous, self-directed AI.
But before we get too deep into the weeds, let's just pause for a second and address the elephant in the room. You've probably heard a massive influx of new terminology lately. And let's be real, some critics are looking at this latest phase, this whole idea of autonomous loops, and they're calling it token-burning AI slop. They think it's just another marketing buzzword designed to sell more cloud compute. Well, in this explainer, we're going to actually unpack the architecture. We want to see if there is real, tangible substance here, or if it's just industry hype.
Okay, let's dive into this. Here's our roadmap for today. We'll start with the AI engineering evolution, then we'll enter loop engineering. After that, we'll do a direct prompt versus loop comparison, break down the 6 core components, and finally, we're going to ground it all in a real-world use case. Let's get right to it. Starting with section 1, the AI engineering evolution, and stacking the scaffolding.
So think of this entire evolution sort of like a set of Russian matryoshka dolls. Every new phase we've seen hasn't actually replaced the last one. Instead, it's a brand new layer of external scaffolding that was built specifically to solve the limitations of the layer right inside of it. First, we had prompt engineering, then came context engineering, then harness engineering, and finally loop engineering acts as this latest outer shell. Basically, as AI tasks grow more and more complex, we're essentially just stacking one operational loop right on top of another. Let's briefly break down exactly what these earlier layers were designed to do. Let's take a totally ridiculous question, like, how many cheeseburgers can I fit between the Earth and the Moon? This absurd, yet brilliantly simple question perfectly represents classic prompt engineering. You give the agent an implicit instruction, and it relies solely on its internal reasoning and its pre-existing training data to give you an answer. It doesn't need external tools, it's not surfing the web, it just computes based on what it already knows inside its own static context window.
But what happens when that internal static knowledge just isn't enough? Say you ask the AI, what is the latest discovery that NASA made? Well, now we've entered context engineering. To answer this effectively, the AI has to be given the autonomy to invoke external tools, things like searching the live web, pulling from databases, or reading external files, to actively fill its own context window with fresh information. It's basically creating a loop of gathering external data until it has enough context to accurately answer your prompt.
Okay, so far so good. But what if your prompt is, hey, can you clone the entire NASA website? Now we're talking about a massive, multi-step operation. And honestly, context engineering completely struggles here because tasks taking longer than, say, 5 to 10 minutes make the context window what engineers call leaky. It's literally like trying to hold water in a sieve. Important details just get lost or forgotten in the memory buffer as the AI constantly summarizes its own progress. And that is exactly where harness engineering comes in. It provides an external system, a harness, to meticulously manage the agent's runtime and context from the outside in, keeping it focused as it executes this massive, long list of subtasks.
Which brings us to section 2, enter loop engineering, the final layer. So if the harness is out there successfully managing the runtime and the memory for massive tasks, you might be wondering what's actually missing from this whole engineering equation. Well, enter loop engineering. This is an external scaffolding layer that specifically targets human interaction. It's what enables an AI agent to prompt itself and self-guide its tasks based entirely on its own internal assessment of what needs to be done. And notice the absolutely crucial difference here. Every single previous phase we just talked about required a human being to sit at a keyboard and initiate the prompt. Loop engineering, it targets the ultimate bottleneck in the entire workflow, us, human initiation. Moving to section 3. Prompt versus loop engineering, the shift in agency. Now, what's really interesting about this slide is that it represents a profound paradigm shift in agency. We aren't just saving time here. We're moving from a world where humans are the absolute instigators of every single digital action to a world where agents actively hold the reins of their own long-term workflows. On the left, you've got prompt engineering, which is inherently human-guided. The AI just sits there completely idle until you hand it a command. But on the right, loop engineering is self-guided. The agent is evaluating a live environment, it realizes an action is required, and it literally prompts itself to execute the task. It's the difference between a car you have to steer every inch of the way and a vehicle that actually realizes, hey, I need an oil change, and drives itself to the mechanic.
All right, Section 4, the 6 core components for building the loop.
Now, if all of this sounds like some kind of theoretical magic, software engineer Adi Osmani laid out a brilliant framework showing it actually takes 6 specific building blocks to make this a stable reality. We've got automation, work tree, skills, plugins and connectors, subagents, and state. We won't get bogged down in the deep theory, but the crucial takeaway is this. An agent needs skills and plugins to actually access live knowledge bases. It needs subagents to verify its own work independently. It needs a work tree, which is essentially a safe digital sandbox to prevent runtime contamination while it's multitasking. And of course, it needs a persistent state to know exactly where it is in a really complex, ongoing process. And that perfectly sets up Section 5, a real-world use case, the World Cup website.
Let's take all of these theoretical buzzwords and ground them immediately in reality, okay? We're going to look at building and maintaining a dynamic World Cup sports website. This shows perfectly why loop engineering isn't just some experimental gimmick, but a highly necessary evolution for complex software. So in standard harness engineering, here's exactly how this plays out. Step 1, you ask an AI coding agent like Codex to build you the site. Step 2, the agent uses its context and harness to write the code beautifully. Awesome, you've got a great functioning site. But here is a massive problem that hits in Step 3. The World Cup happens every single day. Scores change constantly. New user bugs pop up. To maintain this site, a human engineer has to sit down every day, exhaustingly prompting the agent over and over again to fetch new scores, update the database, fix reported bugs. The human literally becomes the maintenance bottleneck. So instead of those manual, exhausting prompts, you apply the loop. And this brilliantly illustrates the set-it-and-forget-it nature of loop engineering. You schedule hourly, autonomous checks. The agent seamlessly uses its plugins and skills to access a live knowledge base for the latest scores. And when a bug is reported by a user, the AI actually prompts itself to fix it, spinning up subagents to verify the new code in an isolated work tree so it doesn't accidentally break the live site. The entire loop runs completely outside of human intervention. And here is why this matters to you. It removes the manual drudgery. It frees human engineers up to focus entirely on creative, high-level architecture rather than just exhausting daily maintenance tasks.
Which leaves us with a truly massive question to ponder as we wrap up today. As these AI agents continue to rapidly expand their scopes, stacking complex loops on top of loops, and crucially, as they start autonomously prompting themselves to do all the heavy lifting, what becomes the role of the human engineer? It's a provocative thought about the future of our digital workflows, for sure, and it's a question we're all going to have to figure out very, very soon. Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you next time.